Hello, friends. Today I'm going to talk about a myth we all heard about. High cholesterol or high saturated fat causes heart disease. But actually, this is promoted by pharma and food industries for a long time to promote their business. Obviously, statin is one of the drugs now we hear a lot, and it is mainly used to treat the cholesterol. And this business, statin business, is almost $1 trillion business, right? And the food industries, mainly carb industries, they want to promote carbohydrates and not saturated fat. So before I go into it, I just want to delve into how the saturated fat that we eat doesn't cause a cholesterol in the bloodstream or plasma cholesterol. Um, when we eat saturated fat or meat with high saturated fat, it gets broken into in our mouth to some extent, and rest of it is digested in our intestine through bile acids. Bile acid is actually made of cholesterol, so without bile acids, your fat that you ate just comes out. It's not a good feeling. So the bile is excreted to break the fats into small fatty acids, and then eventually it comes into becomes a triglycerides as it goes into chylomicron. So, as you know, the fat is a greasy molecule. It doesn't easily get dissolved in the blood, so it needs a transporters. Our body has a intelligent way to transport these lipids. So lipids are not water soluble or aqueous. As a result, the body has a waste mechanisms called transporters. One of the big transporters is chylomicron. If I want to compare or create an analogy, if you take a football field, if a football field is a body and basketball is a chylomicron, tennis ball is an LDL, and beach ball is a VLDL. So these are the sizes, right? So as the food gets digested, fatty acids goes into these chylomicron, which is a fluffy molecule, which is big, and it has the triglycerides, cholesterol, phospholipids in it, and that gets transported through thoracic duct and eventually drops into the bloodstream. From the bloodstream, all the triglycerides and cholesterol goes into our tissues within 3 to 4 hours, right? So life of a chylomicron is probably 30 to 40 minutes, not more than that. So after that, these chylomicrons have apolipoproteins, and these are the kind of sensors for the receiving end. For example, chylomicron has ApoB that is there to dispose the nutrition to the tissues, and it has ApoE that is for emptying the cholesterol, and ApoC is basically activates the lipoprotein lipase, which is available on the tissues. Based on that, these tissues consume the nutrition such as triglycerides, right? So as chylomicron deposits these fatty acids into different tissues, it becomes small and it becomes a remnant chylomicron. The remnant chylomicron has ApoE, and this is an indicator for liver to pick it up, right? So liver senses this and picks it and takes up the rest of the whatever small quantity is there and disposes in the liver. So as you can see, the dietary saturated fat that we ate is pretty much disposed in our tissues, adipose tissue, pretty much within a couple of hours after eating. And remember, chylomicron, the life of chylomicron is 30 minutes or at max 40 minutes, not more than that. Now, what happens in the liver is, let's say if you eat, so this is the dietary fat that you eat, it already disposed into your tissues, right? Consumed in your cells and tissues. Now, liver also generates fatty acids and cholesterol. That whatever liver generates is based on how much carbohydrates you ate. Let's say you have eaten multiple meals of heavy carbs, right? Rice, cakes, pasta, pizza, whatnot. So liver, the way it converts is in our body regulates the blood sugar level very narrowly. So 4 grams, a teaspoon of sugar is available in our bloodstream at any point in time. The rest of it is actually deposited or stored as a glycerol molecules in our liver as well as muscles. There's 100 grams of glycerol is stored in our liver, and remaining 400 grams is stored in the muscles. And this glycerol is very useful for us because if you are in a flight or fight situation, if you need to run quickly or if you need to exercise, high intensity exercise, you need this glycerol, right? So that's why liver always preserves this, glycerol molecules quickly as possible. And the remaining, if you have eaten more than 300 to 400 grams of carbohydrates in a day, which people nowadays, everybody does it, right? So excess glucose gets converted into fat, and this is done through de novo lipogenesis. This is a new genesis of lipids based on the glucose molecules, right? And your liver ships these triglycerides or fatty acids through another mechanism like chylomicron. Now we're talking about VLDL, very large low density lipoprotein, right? So VLDL has a high concentration of triglycerides, and liver generates and pushes into the blood, and these triglycerides are picked up by the tissues and cells. As a result, the VLDL becomes ILDL and becomes LDL, low density lipoprotein. We all heard about low density lipoprotein is the worst form of lipoprotein because it has a cholesterol in it. But in fact, all cholesterol is good, right? It's the context that the cholesterol is in that causes the atherosclerosis. So VLDL now converts to LDL. This LDL molecule is depleted of triglycerides. Now it has a high concentration of cholesterol, and these cholesterol gets dropped into different tissues, and the liver has ApoE receptor. It senses these LDLs because these LDLs are depleted of cholesterol, and the liver picks up these empty LDLs. Now, in some situations, and then also the remaining cholesterol, that excess cholesterol in the cells, is picked up by HDL. We call HDL as a good cholesterol, but as I said, all cholesterol is good. Body doesn't make things that are really bad for us, right? So HDL picks up these remaining cholesterol that is existing in the tissue cells and cleans up and brings all the cholesterol back into the liver. So this is how the cycle of nutrition process goes into the tissues and then returns back through these HDL molecules. The lifetime of VLDL is roughly 3 to 4 hours. LDL is 2 to 3 days, and HDL is 5 days. Now, so let's talk about the cholesterol itself. Cholesterol is so important for our body. In fact, the brain makes its own cholesterol because this cholesterol that liver makes cannot transfer through the blood-brain barrier. As a result, brain needs this cholesterol because all the cells communicate through this cholesterol molecule. It's very useful for neurotransmitters. Body makes roughly 3 grams or 3,000 milligrams of cholesterol. If you eat, body makes a little bit less. If you don't eat, body makes entirety of the cholesterol. Now, all the cells, let's talk about cholesterol. So cholesterol is so important in our body. It is the precursor to all the hormones like insulin, cortisol, adrenaline glands, testosterone, estrogen. All the hormones are made up of cholesterol, and cell membranes are made up of cholesterol. Vitamin D is made up of cholesterol in your skin, in your body, right? So cholesterol is so important. Every cell in your body needs cholesterol. So we have trillions of cells, right? So now let's talk about where the bad name comes for cholesterol. It's not at all cholesterol. So here is where I'm going to bust this myth. So the in a normal situation, when you eat a high carb diet, typically your body's blood is filled with glucose. The excess glucose causes damage on the arteries, on the heart has the biggest arteries attached to it. So, mostly the damage to these arteries is caused by blood pressure, high blood pressure, stress, because stress causes cortisol and adrenaline. They increase glucagon and your blood sugar spikes. There are two types of stress, acute and chronic. Acute stress is good because when you do exercise, you do stress, you have stress, and you need some energy. That's good. But if it is a chronic stress for hours and days, that's where damage, inflammation happens to your body. So in those situations, what happens is the blood pressure increases, and reactive oxygen species increase, and that damage your arteries. If you smoke, if you're alcoholic, they also has a tendency to cause a rupture to your arteries. Glycocalyx is a very thin layer on your arteries that gets easily damaged with the excess sugar in your body. Sugar is kind of a corrosive, like a corrosion that happens to steel and iron. Similarly, the sugar is it causes corrosion of arteries, excess sugar. So stress causes high sugar levels. As a result, the glycocalyx, as it is a thin layer, a transparent layer on your arteries, it breaks, and then it attracts all kinds of, your body has a mechanism, self-healing mechanism. Let's say if you have a lesion or cut in your skin, there's a clotting mechanism happens around that area, and then there is a cholesterol that forms to heal. Cholesterol is a healing, self-healing molecule, right? So same thing happens to your arteries. When there is a rupture or some kind of a damage to that artery, your body is kind of healing it by way of white blood cells, immune system kicks in, and these LDL molecules, bad LDL, actually small LDL molecules get inserted in there, and then they get, and then under stress, there is a clotting happens, platelets, the blood platelets becomes clotted, and its natural form, because that's how the body reacts to any kind of stress, chronic stress. So these plaques, they get bigger, and there's macrophages come in, because these are all healing mechanisms the body goes through. As it eats, it becomes bigger, and it becomes a pus, like a substance in our arteries, and they break. As they break, they get, sometimes they have tendency to block the arteries. So at the end of the day, when the doctor operates this person who died of heart attack, they see this plaque, and that has full of cholesterol. In fact, cholesterol is a self-defense mechanism in our body. The root of the issue is actually sugar stress, not cholesterol. And I also want to explain, a lot of people think that, eating saturated fat, you become fat. That's not true. In fact, when you eat fat, you lose fat. It's very interesting. When you eat fat, you lose fat. But it's the context. You should not have carbohydrates, very high carbohydrates along with fat. Then you will lose it. So let's take, for example, all the animals that eat, like grass. They are very heavy. How are they getting heavy? They're not eating any kind of saturated fat, right? They're eating grass and cellulose. And that cellulose, as you know, in your body, excess carbohydrates converts to fat. So same thing happens to these animals that eats vegetarian, like grass. They become fat because of excess carbohydrates. Look at the animals that are meat eaters, like lions, leopards, cheetahs. They are very skinny, very agile, very active, very energetic, right? Same concept works for our body also. If you eat more protein and fat, you become lean, very healthy. That's what I've been experiencing. So try to reduce carbohydrates as much as possible and save yourself from heart attacks. Thank you so much. Bye-bye.